Okay, so here we are with a little video about inequalities. I'm going to make a couple of these today so that you can review for your tests. And we're going to start off really easy by just graphing some very simple inequalities that we don't need to solve. So starting off with this one right here, we have x is less than 5. So I know that x can be any number less than 5. But it can't be 5. So because it can't be 5, I'm going to circle the 5 and not color it in because 5 is not included, but any number below is included. And I need to put the arrow here to show that any number past the edge of the screen will work. I also need to make sure that the line is connected over here to the circle to show that any value under 5, including 4.5, 4.9, whatever, are included for any value that is less than 5. Okay? Now, let's try another simple one. We have here x is greater than or equal to 3. So I know that x can be equal to 3, so if 3 works to fulfill this inequality to make it true, I color it in. And the greater than sign means that x can be any number to this side of 3. And there's the graph of my inequality. Pretty simple. Let's try another one here. Let's try x is less than and equal to -1. So I know that x can be -1, so I'm going to fill in the circle here. And the less than -1 takes me to this side. And again, I'm going to remember to put my arrow. And there's my graph. And the last one that we'll do of this type is x is greater than 4. So x cannot be 4. So open circle. But it can be greater than 4, including 4.1, 4.2, so I'm going to draw my line right from 4 and put my arrow that way, indicating that all of those values are acceptable for x. Now, that's really quite simple. So let's try to solve a few easy ones here. So I'm just going to write them all out first. We're going to go with x plus 3 is less than or equal to 2. Then we're going to have x minus 2 is less than 7. Then we'll do 2x is greater than or equal to 6. And x divided by 3 is greater than 2. Okay, so let's try solving these. So for the first one, I want x to be alone, so I'm going to subtract 3 from each side. And that's going to leave me with x is less than and equal to -1. So if I graph that, it can be -1. It can also be less than -1. So there is the graph for that inequality right there. Okay. Now for the red one, x minus 2 is less than 7. To deal with the 2, I'm going to add 2. And I'm going to add 2 to both sides. So these cancel out. I have x over here. It's still less than, and 7 plus 2 is 9. So this inequality would, whoops, see what I just did? There we go. So 9 doesn't count because it's not less than and equal to 9. It's just less than 9. So the circle remains open. And we draw our arrow this way. Okay? Now with the next one up here, I want x to be alone. So if I'm multiplying by 2, 2x means multiplied by 2. And in the work that we did in this unit, a few of you had problems understanding that this is multiplication. You can't subtract that 2. You need to divide by 2 because you're using the opposite operation. The opposite of multiplication is division. So 2x divided by 2 is x, and x is going to be greater than or equal to 3. So down here, x can be 3, and it can also be anything greater than 3. to make that inequality true. With the blue one here, x is being divided by 3, so I'm going to use the same value, 3, with the opposite operation, which is multiplication, on each side. Multiplication by 3 and then division by 3 cancel each other out, so x is going to be greater than 6, but not equal to 6, so I don't color it in. Greater than 6 looks like that. So these are some fairly simple solutions. Not much here will challenge you. Just be very careful about what I mentioned over here, okay, about dividing to make this x stand alone after its multiplication by 2. Okay, now things get a little bit confusing when we have negatives, so let's take a look at a few examples. So what happens if I have negative 2x, just use the same one but change it to a negative. Okay, so I want x to be by itself. The coefficient on x is negative 2, so I need to divide by the coefficient on each side. Okay, now as soon as I divide by 2, or negative 2, whenever I divide or multiply by a negative, I need to flip the sign. Okay, that's very, very important. And so the negative 2's cancel each other out. I get x is less than or equal to negative 3. So less than or equal to negative 3, we're going this way. Now that makes sense, okay? Because values that are shaded in here with the blue arrow will work. So if we just consider our original inequality, what happens if we put in, say, negative 5? So negative 2 times negative 5 is positive 10, and positive 10 is greater than 6. So that works. What if we try negative 8? Negative 2 times negative 8 is positive 16, and positive 16 is greater than 6. So that works. What happens if we try 4? Negative 2 times 4 is negative 8. Negative 8 is not greater than or equal to 6, so negative 4 would not work. So switching this sign is very, very important when you divide or multiply by a negative, because it will give you the set of numbers that will make that inequality true. Let's look at another example, and this time let's look at an example that has division, and you have to multiply it out. So x over negative 3 is greater than 2. So my coefficient here is negative 1/3, and that's what the division by negative 3 is doing here. So I need to multiply by 3, if I'm dividing by 3, and I'm going to do the same thing over here. But as soon as I make that decision to multiply by 3, or even when I know from the beginning that I have a negative coefficient, I'm going to be flipping that sign. So that's x, because multiplication by negative 3 and division by negative 3 cancel each other out. X is less than negative 6. So there's my negative 6, and my less than is this way. Okay, so let's test it out. If I have, my original equation was this. So if I have negative 6, will negative 6 work? Will negative 6 work? If I put in negative 6 for x, negative 6 divided by negative 2 by negative 3 is 2. Is 2 greater than 2? No. So negative 6 definitely doesn't work. That's why we don't have it colored in down here. Let's try negative 9. Now negative 9 should work because it's in our selection. It's in our set here. Negative 9 divided by negative 3 is 3. 3 is greater than 2, so it works. So that's the end of the first video for your revision for the test. There will be another one coming where we will take a look at two-step equations with some challenging ideas.